about strings, but I realized we didn't do a lot with strings. And actually, when it comes to web development, I mean, we use the math stuff occasionally, but almost everything we do is with strings. So I thought we could spend some time and take another look at strings and work on some example problems using them, because this text manipulation stuff is so much of what we do. So a few things about strings. Strings are immutable. That means you can't change them, okay? Some languages let you change a string. And so, you remember we saw you had a string like, 0 or whatever. So we can get a character, but we can't change it. You're not allowed to do this. We can't do that, okay? You can't change a string. So if you need to make a string, a new one, you have to create a new string. And you can copy it over, and there's some other ways you can build strings, but I just want to stress they're immutable, okay? The immutability makes them easier to reason about, because they can't change. So it has some advantages. And most newer programming languages have immutable strings. So that's pretty typical. Okay, so otherwise I think we talked about like the basic structure and stuff, and that's pretty straightforward. There's a package to work with strings called strings, which is pretty obvious what it's for. So godoc.org/strings, and you can see a whole bunch of functions for working with strings. And so I'll just show you an example. So here's toTitle. It takes a string and turns it into title case. Okay, so we have hello world, and that just prints the lowercase hello world because we're just printing it out directly here. Now, if we want to make the title case, we can use strings.toTitle. And title case, like
book title.
Yeah, like uppercase, but for only the first letter. And we have to import strings. Okay, are we following that? The strings, and then we can use it. And we're calling the function in strings called toTitle, which we got from here, toTitle. So notice it takes a string and turns string. And it tells it what it does. It returns a copy of the string with all Unicode letters mapped to their title case. Okay, so it's all caps, right? That's confusing. It's not what you'd expect, right? But it mapped every character to the uppercase. So, but anyway, there's lots of other things in here that do it.
Just plain titles that we
Yeah.
were expecting.
There you go. But like I said, the docs did say exactly what it did. So this one says, returns a copy of the string with all the Unicode letters that begin words mapped to their title case. Okay. And then apparently there's a bug. So it turns out this whole title, lower, uppercase, it's easy in English, but other languages it's not quite as clear what the meaning of all those things are. So there are some exceptions and stuff, and that's what they're talking about. But there's lots of functions in here for working with strings, okay? And it's the use of things like this where we can build and manipulate and transform strings into other things, okay? And so I'll show you a couple other examples of commonly used operations with strings. So for example, replace. So suppose I had a string hello name. We saw that before in one of the examples where we made that example program where we replaced name with the person's name. And so how would we do that? We can give, so if we look at the function replace, it says returns a copy of the string s, so that's the first parameter here, with the first n overlapping instances of old replaced by new. So the old thing replaced with the new thing this number of times. So the old thing here is name, the new thing is your name, and then the number of times, I'm just going to put 1. There is a thing that says you can put -1, and there's no limit. So you could do that if you wanted. But this is going to replace name one time with my name, right? So we do replace a lot. That happens very often. Later, we'll probably talk about regular expressions, which are a more advanced way to do the same thing. Significantly more advanced. But you can see the basic idea here. Just replace. And so we do that a lot. You know, replace commas with new lines, or new lines with commas, or all kinds of stuff. Replace all the spaces with tabs, or something like that. Let's see what else we have in here. There's split. We'll do split when we talk about slices. We saw some of these basic transforms. Trimming, it removes spaces on the sides, right? That turns out to be pretty handy. So if I have all this extra space inside of my string, I can do strings.trim space, and that will fix it. So it took out all the extra space at the beginning and at the end of the string, and just left it with just the text. So it made it just that, those 4 characters. So you use that a lot. The trim has the regular trim has the ability, you can specify what you want to remove. Like I could trim out the letter A or something like that. But a lot of other things in here that are useful, okay? So, that's the strings package. It's mostly just those functions. There is a reader. When we talk about I/O, we'll see how we can use that. But basically, it's just functions that you just call. Really straightforward. The other package that we often use with strings is strconv, string convert. And this converts things to and from strings, okay? And so there's a few different ones in here. This is the I2A, which I think I showed you yesterday. This converts an integer into a string. But there's others here. You can parse an integer, and that you can specify the base and how many bits. So actually, let's look at an example of that.
Is it into A because into ASCII?
Yeah, well, let's look up the original definition here. That's a good question. Does anybody just know that offhand?
Is that like a C thing? I haven't taken C.
Yeah, I think it's into Steve. That's the other way around. Is A to I. So Steve.
Yeah, I think it's probably ASCII, but it might be array. But anyway, it is. Yeah, that's where it comes from. Is C.
All right.
And you're right. There's also A to I, which is also in here. A to I. Take a string, turn it into an integer. Notice this one returns an error, right? Because if I take the string ABC, convert that into an integer, that's meaningless, right? ABC is not a number, so that would return an error. But the reverse case is not true. Any integer can be represented as a string, so you don't need an error there. But let's look at parse in, because it's kind of interesting. Okay, so we have parse int. It takes a string, so let's give it yeah, actually, I'll do hexadecimal. You guys know what hexadecimal is? No? Yes?
Base 16.
So it's a base 16 number system, not a base 10 number system. Okay. The nice thing about base 16 is it works well with base 2, and so we use hexadecimal often, whereas base 10 is not a nice fit for base 2. So you'll see hexadecimal numbers. Actually, you guys probably use them with CSS, right? The colors are done in hexadecimal. So imagine we wanted to convert colors into numbers, right? And so we got this, and we want to convert it. So we do parse int, and we give it a base. The base here is 16. Oops. And the bit size, it could be 64, whatever. You know, it says here, the bit size specifies the integer type 0, 8, 16, 32, or 64. And it always returns an int64, but you could truncate it to get the smaller one. But anyway, that's, you tend to use the I to A directly and not parse in. But the typical parseInt would be parseInt your number, comma 10, comma 64. And that would,
Do you know what number that is?
no, but I think it is a valid number. There you go. So 114700965, that's the number, for whatever that's worth. And then it returned nil. Nil is not an error, okay? So parseInt can return an error because, you know, if I have something in here which is not hexadecimal, for example, x, I get an error parsing AF0875X, invalid syntax, okay? Because X is not a hexadecimal character. You only have 0 through 9 and then A through F. Those are the only valid hexadecimal characters. Okay?
What is the type of the error? Is it a string?
It depends. When we cover interfaces, I'll cover in more detail, but it is an error. An error is an interface, and there are lots of things that can implement that interface. And so I'm not quite sure of the exact error. We could probably look at it.
Does it matter if it's an interface and then Java programming and use the interfaces?
Well, it's a little different how interfaces work and go, but we'll see it. So it returns a syntax error. So whatever that is, it's defined in here. The point is, an error has a method on it called error that you can call to get the string representation. But yeah, so it returns this error syntax, which is defined up here. Error syntax. So you can check for that if you wanted. You could say if error equal error syntax. Or you can just say if error is not nil, then I've done something wrong. You often don't care what the actual error is. You just care that there was an error. So yeah, you can use some of these other functions in here. We do use like parseInt and parsefloat fairly often. The basic idea is pretty straightforward, and the reverse, operations as well. So everybody following that?
What's the reverse of parseInt?
Format int.
Format.
This one.
So parseInt will take something and turn it into an int. Is that right?
That's right. It takes a string and gives you an int, and format int takes an int and gives you a string. So actually, we can see that too. If I have this hexadecimal number and I want to format it. Sorry. You can write a hexadecimal number this way. You can use 0x and then the digits. And so you can write directly in Go, instead of like writing a decimal number, you can write a hexadecimal number.
So you put in just there like well, I thought format it took a string and gives you an int. Format it an int.
No, it takes a number and a base and gives you that number in that base. So this is going to return 1, 2, 3 in hexadecimal, okay? Which is 7B, apparently.
Okay.
Following? And so then if you parse this as hexadecimal, you can get back 1, 2, 3. So I've just converted a decimal number into a hexadecimal number by using this, okay? Technically, I've converted an integer that I entered as a decimal.
And this is part of the string convert because it's taking it, putting it in, making it a string.
Right.
All right. So format it does.
Right. And so the reverse here. What is that going to print? That's the question. So I've taken. So in Go, you can also break up expressions that are really big like this. They might be unwieldy into multiple lines. Though if you do this, you have to add a comma. Okay. So I'm formatting this as a hexadecimal number, and then I'm going to parse it back out again. So I should end up with the same thing, right? Yeah. So I convert it to a string and then back again.
Can you just talk through that function one more?
Yeah. So this takes 23 the number, converts it to hexadecimal, and makes it a string.
Just because it's 16, that makes it hexadecimal.
That's hexadecimal, base 16. And so you're going to end up with a string 17. Okay? And then I'm going to parse that string base 16 again as a 64-bit integer. And then I'm going to print it. Okay? This function returns that number and a possible error. And so when we ran it, we saw that the number was this number, 123, and there was no error. So we basically, we formatted it and then unformatted, back and forth. Right? Follow? We've done the reverse operation. So.
Why do you need a comma on line 14? It just seems like that's the end of the format print line statement.
In JavaScript, if you make like a big array, you guys have seen that, right? Where you do like A, comma, B.
Yeah, I'm
And
just,
you can't have a comma here in JavaScript.
right.
So Go says you can have a comma here, which makes it easy if you wanted to comment out that line, right? You can just comment it
Or
out.
if you're going to add on, forget it.
And it not only says you can, it says you must.
I got it.
So if you have an expression that breaks across multiple lines, you have to have a trailing comma, okay? Which does look a little weird, but it makes it a lot easier to, like I said, you can comment things out, change things easier because of it. So technically JavaScript does allow it, but none of the implementations of JavaScript allow it. So it's kind of the spec actually says you can do that. It doesn't work. So yeah, there's some other things in here. But so basically we use strings and we use strcom to write programs that use strings. Okay, so now we're going to look at some example programs for doing strings. So remember that program we had that converted miles to kilometers? And we had a really simple thing. So this program should be pretty straightforward. What we want to do is do the exact same thing we did before, except now we want to like have this nice pretty ASCII art format, okay? So we want to print it out in this format. Okay, and I think we have everything we need to be able to do that. Okay? Everybody following? And also notice that I said format to 2 decimal places. Which I showed you how to do. So let's try to make that program.